Hi, class. I love you guys so much. You're so fun to teach. Just want you to know that before we get started. Alright, you guys ready for lesson 36? I know I am.
Here we are, lesson 36. Go ahead and do the warm-up if you haven't done it, and then turn this back on and check your answers. Ready, go. All right, here are the answers to the warm-up. Now when you multiply anything by 10, you just move a digit over, or the decimal over one place value. So $1.45 times 10 is $14.50. This one I did 4 times $1, so that's $4 plus 4 times 50, which is $2, so we get $6. This multiplied by 4, so you get 16. These we multiplied by, or no, we divided both by 6, so we get 4/5. 12 minus 9 is 3, and 40 divided by 10 is 4 times 9 is 36. So give yourself a pat on the back if you got all those right. Now we're going to talk about ratio. I know we've done this in the past in the last math book, but if you hadn't come from that math book, let's do a little review. All right, in a group of 28 children, there are 12 boys. What is the boy-girl ratio? So what we do is write boy, girl. Because it's boy to girl, whichever one comes first goes in the numerator. Whichever one comes second goes in the denominator. Okay? Boy-girl ratio. Well, we know there are 12 boys. But how many girls are there? Well, there are 28 total. So we have to do 28 divided by 12. We have 14 girls. So that's the ratio. But we never leave ratios as a fraction that needs to be reduced. We always reduce them. So that actually is going to be 6 to 7, or 6/7. Girl-boy ratio means girl in the numerator and boy in the denominator. And so we would just flip that. It would be 7 to 6. Example 2, the team won 4/7 of its games and lost the rest. What was the team's win-loss ratio? What is the team's win-loss ratio? Okay, if it won 4 out of 7, think about this. They won 4, total were 7. So the loss was 3, right? Those need to add up. So these have all the numbers we need. So win to loss ratio would be win over loss. So we take 4 to 3. Example 3, in the bag are red marbles and green marbles. If the ratio of red marbles to green marbles is 4 to 5, so I'm going to say red, green. I mean, it's always good to organize your data. Okay, red, the ratio of red to green is 4 to 5, so that's red, that's green. And we probably need total because we're talking about fractions, so total would be 9. Then it says what fraction of the marbles are red? 4 out of 9. 4/9 are red. All right, let's talk about probability. This is important to know. Probability is the number of favorable outcomes divided by the number of possible outcomes, meaning what you're looking for out of all the possibilities. Okay, let's look at what that means here in a problem. Okay, a single dot cube is rolled. So here is a dot cube. Mine kind of looks kind of cool. Usually they're white with black dots, but this came from a cool game. So we call it a pair of dice. Okay, so when they say dot cube, it's what you've played games with. Okay, and they range from 1, 2, 3, 4, 5, all the way up to 6, and you know that. So they're saying, if you wanted to roll a single one of these, what's the probability of getting a 4? Now remember, I'm going to write it back at the top here. probability equals the number of favorable, means what you're looking for, outcomes over number of possible outcomes. So if we're looking for a 4, how many 4s are on this thing? 1. And how many possible results are we going to get? 6. So 1/6 is the probability of getting a 4. A number greater than 4. Well, how many events could be greater than 4? How many of these are greater than 4? Well, I see 5 and 6. There's only 2 possible, or 2 outcomes that are greater than 4. Out of 6, when we roll it, you got 6 things that could happen. So we always reduce that as well. Number greater than 6. Well, let's look at our die. How many of these are greater than 6? None of them. So the probability is 0 out of 6, or 0. Number less than 7. All right, how many of these things are less than 7? They all are. There are 6 results that are less than 7, so you'd say 6 out of 6, meaning 1. And when you have a probability of 1, it means it's going to happen every time. So every time, we're going to get a number less than 7 when we roll this thing. You're going to see this kind of problem with spinners, okay? And you guys can do, think of all the games you've played at home where you might not have realized it was all about probability and chance. The face of a spinner is divided into 5 equal sectors, and the reason we want equal is if one was bigger than the other, it's got a bigger chance of landing there. So they have to be equal in order for us to calculate it this way. If the spinner is spun, what is the probability of the spinner stopping on a 3? Okay, well, how many 3s are available? There's 1. And out of how many possible spots it could land? Out of 5. So 3/5. What's the probability of not stopping on a 3? So how many chances, or how many spots are not a 3? 1, 2, 3, 4. 4 areas that are not a 3. So the probability is 4 out of the 5 total. Example 6. Look at this now. They're not equal, are they? In fact, this one is double these two. All right, what's the probability of this spinner landing on a 3? And this is how we write it too. I forgot to write you. We would say probability of a 3. That's how they write that. Probability of 3 equals. Well, doesn't it look like we need to kind of use these into 4/4, and 2 of them are 1s. Does that make sense? We can get 2 chances of getting a 1. So what we want to do is imagine that that is in 4ths. So we'll work in 4ths. If it stops on a 3, again, it's going to be, it only has 1/4 of a chance of getting a 3. All right, practice now. Let's go ahead and do these. You can turn me off and check your answer key. If you get stuck, come back and check in with me. And ready, go. All right, in the pond, we're 240 little fish and 90 big fish. So what was the ratio of big fish to little fish? It would be 90 over 240, which we know how to reduce. We would say 9 out of 24, and that reduces to 3/8. 14 of the 30 children at the party were girls. What's the boy-girl ratio? Boys to girls. And 14 of the children were girls, so 14 goes on the bottom. How many were boys? 16. Let's reduce that. We get 8/7. Next page. Okay, the team won 3/8 of its games, so that means it lost 4/8. What's the team's win-loss? Win to loss would be 3, and then it lost 5, so 3-5. The bag contained red marbles and blue marbles. The ratio of red marbles to blue marbles, so I'm going to say red to blue, was 5-3. What fraction of the marbles were blue? Blue, there were 3 blue marbles out of 8 total. Now we're into probability. What is the probability of rolling a number less than 4? So what I'm going to say is probability of rolling less than 4. That's how we write that when we get into stats. Probability of rolling less than a 4 with one toss of a cube, something less than 4. Well, I've got a 1, 2, or 3. So 3 things are less than 4 out of 6. So a half of a chance, or probability is 1 to 2, or 1/2 that you're going to get something less than 4, because half of the numbers are less than 4. Now we're going to look at the spinner. What is the probability of it stopping on 3? So we're going to say probability of getting a 3. Well, there's 1 3 out of 4 sectors, so it's 1/4. Probability of stopping on a 5. Probability of a 5. There are no 5s, so it is 0. Never going to happen. What is the probability of the spinner stopping on a number less than 6? How many numbers less than 6 do we have? All of them. So I'd say probability of a number less than 6 is all of them. So you could say 1 or 4 out of 4 reduces to 1. Letter F, we're going to look at a new spinner. What is the probability of it stopping on A? Well, half of the area is A. So 1/2. Or we could have said 2 areas, 2/4, which is 1/2. All right, not stopping on a B. So it's not going to land on B. So it's going to be one of the other 3 areas. So it's probability of not B equals 3/4. All right, enjoy.